Hi, Joe Cerrone. Welcome to this week's Zoom meeting for CAD 230, Introduction to Solidworks. This week, we'll be covering Module 8. Module 8 goes through creating threads and modeling threads. We're going to take a look at that. Modeling threads is a newer, it's actually a macro that SolidWorks created, because the way they teach how to model threads here is that we will model the threads, and there is a new tool called the threading tool that works great. And it came out about 3 or 4 years ago now. It's getting a bit dated. But prior to that, we would have to create the geometry for the thread by looking at a machinist handbook and looking at the major and minor thread diameters, and then we would create a triangle for that. And I'll talk about that as we go on. But basically this week, you're to create lab 8A, which is this threaded part here, 8B, and 8C. And if we take a look at those labs, we'll take a look at lab 8A first. So here I have my purple threaded part. And if we take the way back bar and we come back to the beginning of it, and then we look at the sketch, and we hit the space bar and we say normal 2. What we did here was we created an axis with a construction line at the origin, and then we drew the part, the outside profile of the part right here. And if we dimensioned it properly with ordinal dimensions, we'll get a fully defined part. Once we created the part, then what we did was to revolve it. And then we use this threading tool. And if we look at the thread by editing the feature, this is really a terrific thing, because it's very much like the hole wizard, where the geometry is perfect for these standard fittings. And so when we create a thread, and just as sort of an FYI thing, if you haven't created threads like me, you didn't grow up in the metal shop, you can put down, let's go to Google, and then we'll say thread die. So a die is a metal component here, and it's got these ridges on it. And the way that it works is that you create the external geometry shape, and then you put the die into this handle here, and then you put it into a vise like this, and you just turn the knob, turn the handles until it cuts the threads, and you'll use a threading oil, tapping oil. So this is how you would create an external thread. And what I recommend you do is you go to Harbor Freight if you are going to do 3D printing, and you pick up a set of these. They're about $10. And so if we were to get a thread kit from Harbor Freight, and you could get them from anywhere, but it's the cheapest. And so for $20, you can pick up a set of threading tools. And I recommend that if you are going to be doing 3D printing, as you start to pick up on things, having a set of tools like this. What I usually do is I will thread the part, and then I will chase it down. I will 3D print the part, and then I will chase it down with a die. And a die is used for the external threads. Now that you know how a die cuts external threads, we can look at the threading tool. And then what we do is we choose these different standards. And so as we look at this part, what we do when we work with the threading tool is we pick this edge. And this one isn't quite a good one. As I look at it and I look at the way that it's set, the problem with it is if I look at it really closely, you won't be able to get the part onto the thread because it doesn't start and have a run out. And so when I use the thread tool, what you want to do is you want to use the offset right here, and you want to offset it a little bit, and you want to offset it to the direction where it comes off the part, either this side or that side, but it has to be offset. And so I'm going to say, let's offset that 0.125, 1/8 of an inch. And let's go the other way, like that. And so that way the thread lands between this little trough here and this one here. And that's kind of what you need when you cut threads on a machine called a lathe. And so by offsetting the threads, what that'll do is that will give the thread a way to begin with the run out. And so that's how I would fix that. And then as we look at the thread tool, we edit the features. We can see that we chose this edge over here, and then blind means we just tell it how long that's going to be. If we chose, thread it up to an edge, just like when we do with extrusions, we could do that. We used an inch or imperial units versus millimeters. And then it was a 1.25-12, which means that the diameter is 1.25 and the number of threads per inch is 12. And so if we were to count the ridges, we would get 12 threads per inch. And then we would cut that thread. We use right-hand threading tools. Typically, those are the standard righty-tighty, lefty-loosen kind of threads. And that's basically it. So we put that thread on there. And then it does take up a lot of geometry space when you work with Solidworks, because what it does is it actually creates this helix and all the geometry. So if you have like 100 of these threaded inserts on an assembly, it'll really bog down your machine. So most of the guys, unless they're going to be, making a prototype, will use other ways to represent threads. They'll represent threads with just schematics rather than with actually going through and creating the thread itself. And so that's how the thread looks. We mirror that, and then we apply that thread to the other end. And then if I look at the other end and I want to fix that other end, let's take a look and see. Again, the run out isn't quite right here. It would be difficult to get that on there. So if I edit this thread feature and adjust the offset 1/8 of an inch, let's go the other way. And then we green check mark it. I can then bring it into 3D printing. And some of you guys are in the 3D printing class. I've actually got my 3D printing software up. Let's see if it's running. It's not happy, so let me turn that off. But the way that you would be able to bring that into a 3D printer would be to save this as an STL. And so what we would do is we'd say save as, and we'd save that as an STL. And I'd say save it. Yes. And then I'd go into a Dremel 3D printing or a slicing software like Cura. And this is the build plate for a 3D printer. I use the 3D 45s. And what you would do is you would open up the file. And so let me get into my 2020. It seems to be where I keep everything. And then I go into my 230, 2020. There it is. And so here's my threaded component. And then what we do is we prepare it in the slicer using polylactic acid or PLA. Prepare it. And then I can look at the layers and see how that would come out. Typically, when I 3D print something that's round like this, what I recommend people do is you stand it up on the edge, because when they're up on the edge, the round cylinders stay more cylindrical in shape like that. And then I'd have to re-prepare it. It would take 43 minutes on a 3D printer at low quality in a horizontal orientation and a vertical orientation, 5 more minutes. little less than that, 43, 3 more minutes. And we could 3D print that. And it's really a great way to go through and test your prototypes. Back to the main information. So this is lab 3A. It uses the thread wizard. And then if we look at lab 3B, and I think we'll go to the nut. This is actually 3C. The other technique, and you can use other CAD systems for this, like AutoCAD, is to create a helix and then to create a spiral sweep. And so what we would do here on this one would be we'd create the geometry for the nut. And by the way, I used to teach technical drawing up at Northern Illinois University as a graduate student. I used to do all the drafting labs. And so that's the first thing we started people out with was fasteners. And then we just put this revolve cut around it. It basically is just a rounded shape, created a plane, and then we created a helix. And then what we did was we created the geometry for this cut sweep. And so if I look at this cut sweep geometry and we look at the sketch, what we do is we create the triangular shape for the depth of the thread. And so this would be you would get this information from what's called a machinist handbook. And so if we were to take a look at that, where we went into thread charts, let's just go with thread geometry. Let's see if yeah, this is perfect. And so if we look at the images for that, the way that we would create threads would be like this. With an external thread, you have a minor diameter, which is the valley, and then you have a major diameter, which should be the outside diameter of the part, maybe a little bit less, depending on it. And then the pitch is the distance between each crest of each thread. So when you start reading the threads per inch, like the one that we just recently had, I think it was 1¼ - 10, then you would count 10 of those pitches in between each of the crests. All right, and so as we look at that, then what we would do is we would sweep that geometry around and then subtract it, or sweep cut. So they make you do it the hard way, and they show you the easy way in the beginning, in case it does fail. And then if we look at the last assembly, and it's not really 100% fair. One of the students just said, how do we create assembly? And it's in the next chapter. I'd be happy to demonstrate that. If you can't figure out how to do the assemblies, it's done with mates. And what I'd recommend you do is you just look at the chapter 10, or chapter 9, which is the next chapter, which goes through and shows you how to create mates and assemblies. And assemblies are really a terrific component of SolidWorks. That's what makes SolidWorks so popular, is that you can visually troubleshoot all of these different components and see how they fit together. And you can actually go in, and there's a number of things you can do with SolidWorks to simulate motion and to see how everything fits together. All right, so back to the main splash page. That's our assignment for this week. Complete lab 8A, 8B, and 8C. And then next week, we're going to start going into assemblies. And so I've turned on module 9. I believe it's 9. Yes. And so 9 takes you through the bottom-up assembly techniques. Here's some components that we did when we revolved. And here's some other components that we did with extrusions. And then there's this gate assembly, which is a pretty big task, but give it a shot. I think you'll do fine with it. So we'll start going into assemblies. And as we go into assemblies, if you're looking for some extra work to do, that's a great time to start looking at the 3D printer lab. This is a really good project where you can create the threads, you can create these different components, and you can get a few extra points, and you can get yourself a 3D printed bench vise, which is a nice vise to have. And so this exercise is here in the extra credit area. All right, back to the main splash page. So that's this week's Zoom meeting. Be sure to complete Lab 8A, B, and 8C. Looks like the midterm went quite well. If you haven't finished the midterm, you have until 11:30 p.m. tonight. And other than that, I'm going to end the Zoom meeting and open things up for questions.